In this problem, we're given the mass of a ship, and we want this ship to float. So how much water, fresh water, must it displace? So this floating vessel, any floating object, if it's floating, then the force of gravity is going to be equal and opposite of the buoyant force, so that the net force equals 0. So this buoyant force must equal the weight of the object. So I'm going to label that the mass of the object. Well, it's also true that the buoyant force must equal the weight of the fluid that's being displaced. The weight of the fluid is the density of the fluid times the volume of the fluid times g. This is true again because mass is equal to density times volume. So the mass of the fluid is the density of the fluid times the volume. All right, so if this is true then, that the weight of the object equals the weight of the fluid, then those g's can cancel out. And the volume of the fluid will equal the mass of the object divided by the density of the fluid itself. So we take our ship, 4.4 million, so 4.4 times 10 to the 6 kilograms divided by 1,000 kilograms per cubic meters, the density of our water. The kilograms cancel out. 10 to the 6 divided by 10 to the third, you could reduce that if you wanted to, but 4.4 times 10 to the 6 divided by 1,000 should be 4,400. 4,400 cubic meters of water must be displaced to float a 4.4 million kilogram ship.